In this video, I'm going to show you how to use the secant and tangent Pythagorean formula to simplify trigonometric expressions. Now, this formula here is not the secant and tangent Pythagorean formula. This is the cosine and sine Pythagorean formula, and you should be familiar with this. If you're not, then there's a previous video that can help you understand where this comes from. But we're going to use this as an initial stepping stone to get to the secant and tangent Pythagorean formula. So we're going to start with this formula right here, and we're going to divide every term by cosine squared. So we're going to divide cosine squared by cosine squared. We're also going to divide that sine squared by cosine squared, and we're going to divide 1 by cosine squared. We're just dividing the entire equation, both sides of the equation, by cosine squared. And the result here is cosine squared divided by cosine squared, that's just 1. And then sine squared divided by cosine squared, that's just tangent squared. And then 1 divided by cosine squared, well, that's just secant squared. So here we've got another formula which looks pretty similar to the cosine and sine Pythagorean formula, but now we've got tangent and secant. 1 plus tangent squared equals secant squared theta. So this formula is really important. It's almost as important as this cosine and sine Pythagorean formula, and we're going to be using this formula, the tangent and secant formula, in particular in these coming examples. Here's a first example, and this is a pretty simple example, but don't worry, it'll get harder as we do more examples. But for our first example, we're going to start off pretty simple. So we've got secant theta divided by 1 plus tangent theta, and we want to simplify this expression. And we can simplify this expression by looking at the secant and tangent Pythagorean formula. Well, secant and tangent Pythagorean formula tells us that 1 plus tan squared theta equals secant squared theta, and here in our denominator, that's exactly a 1 plus tangent squared theta. So we can substitute secant squared in for that denominator there. So let's go ahead and do that. So we've got secant theta divided by secant squared theta. And now that we've done the substitution, this expression can be simplified a whole lot. We can divide top and bottom by secant theta to just get 1 over secant theta, and 1 over secant theta is just cos theta. So there we go. This expression here just simplifies to cos theta, and we can figure that out using the secant and tangent Pythagorean formula. Here's another example. We want to simplify this trig expression using the secant and tangent Pythagorean formula. But this time we're going to simplify the expression a little bit first, because there are other rules that we can use to simplify it before we have to use the secant and tangent formula. So first of all, this cosecant theta. Tangent squared theta divided by cosecant theta. Well, 1 over cosecant theta is just sine theta, so we can turn this expression into sine theta times secant squared theta minus sine theta times tan squared theta. And now since we've got a sine and a sine, we can simplify a bit more by factoring out a sine. So here we've got sine theta times secant squared theta minus tan squared theta. And the secant squared theta minus tan squared theta, that looks like it could be simplified using the secant and tangent Pythagorean formula. And indeed it can, not in this state, but once we rearrange it a bit, then we can get a secant squared theta tangent squared theta. So let's do that. Let's rearrange it a bit. If we subtract tangent from both sides, then we get a secant squared minus tangent squared, so let's do that. So 1, and then subtract tangent squared, so the tangent squared goes away. 1 equals secant squared theta minus tangent squared theta. And so that tells us that secant squared theta minus tangent squared theta is just 1. So this secant squared theta minus tangent squared theta, that is just 1. So our answer then, we can just simplify this to sine theta times 1, which is just sine theta. So there we go. That's it. This complicated expression just simplifies to sine theta. We can see that using the secant and tangent formula. Here's another example. We want to simplify the expression tangent to the fourth plus 2 secant squared minus 1. And just looking at this expression, off the bat, it doesn't look like there are any easy ways to simplify this expression by itself. So we have to turn to the secant and tangent Pythagorean formula. Now, in the past, we've looked to group two terms up into a single term using the secant and tangent Pythagorean formula. We've tried to use this to reduce the size of the expression. But here, it looks like however we use this formula, it's going to increase the size of this expression. It's going to add additional terms. Now, that might sound like a bad thing at first, but it turns out, in this example, if we substitute for tangent to the fourth and express that in terms of secant, some terms will cancel. Even though we increase the size of the expression, some terms will cancel, and the end result will be a smaller expression. So let's go ahead and do that. We're going to substitute for tangent to the fourth here using this secant and tangent Pythagorean formula. So let's solve for tan squared, and then square that to get tangent to the fourth. So solving for tangent squared, we subtract 1, we get tangent squared is equal to secant squared minus 1, and then we square both sides, and that gives us tangent to the fourth on this side, and then the right hand side just goes to the square of this expression, which is just secant to the fourth minus 2 secant squared plus 1. So we can substitute this right hand side in for tangent to the fourth here, and we'll do that. So secant to the fourth of theta minus 2 secant squared of theta plus 1, and then we have our original terms plus 2 secant squared theta minus 1. Okay, now it looks like this expression has gotten larger, but look, some things cancel. There's a minus 2 secant squared here, and there's a plus 2 secant squared here. So those can cancel. And there's a 1 here, and a minus 1 here, so those can cancel. And we're just left with that secant to the fourth. So that's it. That's what it simplifies to. Secant to the fourth. For our last example, we're going to simplify cotangent divided by tangent plus secant. And one thing should jump out at us right away. There's a tangent and a secant in the denominator here. So that kind of suggests that maybe we can simplify this denominator a bit using the secant and tangent Pythagorean formula. So let's try to rearrange this formula so that tangent and secant are on the same sides, and then maybe we'll get some insight as to how this denominator can simplify. So to put tangent and secant on the same side of the formula, let's start off by subtracting 1. We'll get tangent squared equals secant squared minus 1, and then we'll subtract secant. So we get tangent squared minus secant squared equals negative 1. Okay, so now we've got tangent and secant on the same side, but these expressions are a little bit different. This is tangent squared minus secant squared, whereas the denominator is tangent plus secant. So is there any way that we can reconcile this difference here? Is the denominator part of this expression in any way? Well, yes, this is a perfect difference of squares. So that means that this can be factored where tangent plus secant is one of the factors. So let's go ahead and factor this expression. We get tangent plus secant, and what's the other factor? Well, the other factor is just tangent minus secant. So if we multiply these two factors, we get negative 1. Okay, so we've got some more insight. The denominator is part of an expression that simplifies to negative 1, simplifies really nicely. But how do we introduce this other factor here? Well, we can just multiply by that factor on the top and bottom. Let's multiply the numerator and denominator of this expression by tangent theta minus secant theta over tangent theta minus secant theta. That way this denominator will take the form of this left-hand side here. So let's write it out again, but with the denominator taking this form. So this comes out to cotangent theta times tangent theta minus cotangent theta times secant theta. And yes, that top can be simplified a bit, but let's not worry about that for now. Let's just write the denominator first. So tangent theta plus secant theta times tangent theta minus secant theta. And now we can go ahead and use our formula here, tangent theta plus secant theta times tangent theta minus secant theta, that's just -1. So that whole denominator will just become -1. So let's write it out again, except the denominator will be -1. So cotangent theta tangent theta minus cotangent theta secant theta all over, this time we just write -1. And we can simplify that a bit. Let's start off by just breaking up the fraction over -1. So cotangent theta tangent theta divided by -1. Well, that just adds a negative sign. So negative cotangent theta tangent theta. And it's the same idea with cotangent theta secant theta, but we've got a negative already, so dividing by negative gets rid of that negative, and we just have plus cotangent theta secant theta. Okay, so now it's time to go ahead and simplify this expression. And we can start off doing that by writing cotangent as 1 over tangent. And since that's multiplying tangent, then we can cancel here, and we've just got -1. Okay, and then the other expression, well, it's not entirely obvious how this simplifies, so let's write it in terms of sines and cosines, and then we can cancel some stuff. So cotangent is just cosine over sine, and then secant is just 1 over cosine. So we can cancel the cosines on top and bottom and just have 1 over sine. So this is just -1 plus 1 over sine, and 1 over sine, well, that's just cosecant, so -1 plus cosecant theta. And there we go. That's our simplified expression. So now we have at our disposal two trigonometric Pythagorean formulas. There's the sine and cosine one, and there's also the secant and tangent one. And in the future, we'll also learn about a cosecant and cotangent formula that we can use to simplify expressions in a similar manner.